All right, how's everybody doing today? Good, midway hump day, right? Right in the middle of the conference, right? Not too early, not too late. The museum's going on tonight for those that are gonna go there. That'd be really cool.
Okay.
So introductions. My name is Fred Fry. I'm the co-founder and CTO at SnapAttack. We are a relatively new company. We're focused on detection engineering, cross-platform with using detection as code, attack as code.
Yeah. So my name is Andrew Rector. I lead the Detection Engineering and Automation team, or DEA. If you're thinking, that's not what DEA stands for, I know, I've heard that before. Poorly chosen acronym, but that's the name of our team. We have two different responsibilities. Our first responsibility is to manage and curate the custom detection package that we use in managed defense. And the second thing is to basically engineer solutions for both our detection engineers as well as our SOC team. So we spend a lot of time building out response automations, things like automated file acquisition, automated data collection, auto-containment, stuff like that.
Great. And so to talk today, we're going to talk about process. Some of my background in history, I have 22 years experience in cybersecurity, hacker from 2000 to 2016. Some of my fellow friends are in the audience. Very heavily focused on offensive red teams. And then 2016, stepped away to help stand up Fortune 500 threat hunting teams. So red and blue teams came together, and that's going to be a lot about what we're talking about is how do we do threat-informed defense and how do we build a program. So what you're not going to see today are the latest mWISE like detections from the technical side of things, but we're going to go through some of our experience in growing these huge detection engineering processes. It's much more involved than just writing the detections. So we're going to talk about how to get funding for your program, how to measure, how to report, a lot of the pain points we're going to be discussing. Some of them were super painful. So we're hoping to kind of impart some of that knowledge that we've had doing it the wrong way and share what we would call like the 5 categories for improvement of your detection engineering process. We're also going to go over some KPIs of how to measure detections. Very, very important to know how to measure. You can't improve what you can't measure, so we're going to talk about that. And yeah, we're going to get into it.
Yeah, so before we start talking about how to actually level up your detection engineering program, we thought we would first start off with definitions, right? Everybody's favorite thing. So before we get started, we have to define what detection engineering actually is. And so, of course, we went back and forth a lot on like what detection engineering actually is. And about 2 months ago or so, like an industry leader, Florian Roth, he kind of came out with a blog called About Detection Engineering. If you haven't read About Detection Engineering, it's a really, really good kind of primer on what detection engineering is. And one of the definitions that he basically proposed was detection engineering transforms an idea of how to detect a specific condition or activity into a concrete description of how to detect it. So let's kind of dive into that for just a hot second here, right? So transforming an idea, what could that look like? So an idea here could be something like a blog, right? Let's use like the DFIR report. If you've ever read the DFIR report blogs, they put out a lot of information on how threats work and a lot of TTPs that you can use to extract information and turn that into a detection. And so you take an idea like that, maybe an attacker writes a file to a specific directory. Well, you need to turn that information into a concrete description of how to actually detect that activity. And so what that might look like would be creating a rule, right? Maybe use like a vendor agnostic rule language like Sigma and convert that into whatever backend that you actually need to convert it to, like Splunk or CrowdStrike. Or maybe you're writing your rule in whatever the vendor language actually is. So something like HXIOC or YARL, whatever that is, right? So that's how we can think about detection engineering and really define it. I am also a huge fan of analogies. So I was talking with Fred recently about an analogy on how I think about detection engineering. So when I think about it, I really want to label as much security relevant events as possible. It's all about labeling events. So to think about this, I kind of thought about, well, what was it like to be like in like an English literature class and like reading a bunch of information? So you can think of the words, right, as the volume of data that you're getting from your network, right? That's all the logs, all the information that you have to write detection content. Well, what do you do with the information that's most relevant for you? You highlight it, right? And so highlighting could be thought of as our rule language, right? We express whatever we want to detect in a rule language, and then you actually spend time highlighting that, right? So you highlight the words on the page so you can remember what the contextual information actually is. So that's really what we're doing with detection engineering. We're spending our time actually codifying attacker activity with a rule language, applying it to data, producing a detection. Where can this be applied? It can be applied to a lot of different locations, right? To security monitoring, that's the most classic example for detection engineering, right? You create a detection that produces an alert, and security monitoring will basically consume that and respond to it. You can apply it to threat intel and malware analysis. Maybe you're ripping apart a binary. You're ripping apart all the information, the things that it's implementing. You write a YAR rule for it. You could apply this to incident response and digital forensics, right? Where you're codifying IOCs and turning that into a rule that you can use to continue to search information across your investigation. So I'm going to try to get a little bit of audience feedback here. So we're going to talk about what detection engineering actually looks like. So PowerShell script block here, right? Is this rule or this query, is this part of detection engineering? Show of hands, yes or no? Yes, this is detection engineering, or no? Yeah, so this will be considered detection engineering in kind of the most classic way, really. This is an actual rule. This is a query. Okay? How about this? A YAR rule. Show of hands? Yeah? Yeah, again, this is detection engineering, right? You're crafting logic to create a rule to label events or label, some information in a binary. What about this? This could be a contentious one. How do we feel about IOCs? Is this detection engineering? Nobody wants to raise their hand? Well, I guess that's the question, right? Is what would you do with this? Would you turn it into a rule? Maybe, right? That might be something that you would do. Or, and hopefully a lot of more modern technology stacks, what you do is you spend time turning it into a threat intel feed, integrating it directly with your SIEM, right? So in some ways, we do consider this detection engineering, but it's one of the most brittle versions of detection engineering, right? This is not going to be the thing that really gives you the most bang for your buck. So we'll spend a lot more time talking about why this isn't a great example of detection engineering, and also why it kind of is part of it. So you can't ignore it. It is important, but it's not a critical part of detection engineering.
Yeah, and just to add a little bit of clarity, I think this is absolutely detection. There is nothing easier to transmit and nothing easier to share than IOCs. It may not be the engineering, right? Unless you're talking about that security workflow and pumping it in. So yeah, we went back and forth. We didn't find a maybe icon fast enough, but this is it's definitely detection. Is it engineering? Yeah, the jury's out.
Yeah, absolutely. Okay, example number 4. Here's a bunch of alerts, right? This is alerts from our alert triage system. What would you say? Is an alert detection engineering? No. I would also agree with that. It's not detection engineering. An alert is an output of detection engineering, right? This is a potential output that may be produced, right, as a result of a detection. So a detection has occurred. That doesn't mean it's an alert, right? Or that doesn't mean it's an alert. But if we're in a security monitoring context, well, in that case, okay, it's an alert, right? That's something that somebody actually has to respond to. But it is not, by the nature of just being an alert, that's not part of detection engineering. That's an output of it, right? And the security monitoring team is consuming that information. They're consumers of detection engineering. Okay, so benefits, right? We're thinking about the benefits of detection engineering, right? The big one here, reduced mean time to detect. So we want to be able to detect the threats as quickly as possible, right? We've heard probably enough talks at this point from Google people that threats are expanding, threats are faster than ever, there's more threats ever than before. So what do we have to do? We have to figure out a way to maintain the queue of detection opportunities and really respond and create detection content as quickly as possible. And so we've spent a lot of our time on in building these platforms. I think one of the fun parts between Fred and I is we basically came to kind of the same conclusion of building out a platform that can really help respond to detection engineering needs as quickly as possible, right? And so the other part here, and we'll talk more about some of the benefits when we get into our section about kind of deciding whether or not you should actually invest in detection engineering as an organization. but you do have the ability to really tune your detection content to your environment, right? If you're in your own organization, you can create detection content probably faster than a vendor or an MSSP, right? So you can have more coverage, more confidence, because you're the organization that's actually made it. Okay, so we're gonna move into the components of detection engineering. I'll pass that over to you.
Yeah, before we get started on this, it's also important, I guess we probably should slide a slide in here talking about where detection engineering lives, right? So later we're going to talk about the maturity of organizations. Many organizations don't need a detection engineering. Maybe they're not large enough. Maybe they can rely on their vendors. But more often than not, some of the larger companies and critical businesses rely on detection engineers and threat hunters to fill that gap where the vendors stop delivering high quality, very tuned signatures and the need is still there to not miss hackers that can slip past those EDRs and antivirus products and stuff like that. So detection engineering is absolutely critical, and why it's critical is it needs tuning in that environment. So it really is kind of a very interesting play right there. But we'll talk about that when we start talking about the maturity of it. Okay, so detection engineering. I mean, if you really want to boil it down to it, there's really two major aspects. There is the technical rigor, the technical detections, the research and development, ripping apart binaries, doing IR, understanding what telemetry data is left behind by certain threats and actors, all of this technical stuff. This is the fun stuff. This is what we really enjoy. Today, we're also going to talk about the process, the systems thinking. How do you manage this at scale? Because this is the way to grow budget. This is a way an organization who might not be able to justify a detection engineer, let alone a team. I mean, we're blessed to have many detection engineers, but we have to justify budget. We have to justify report, measure, output. So we're going to talk about that. We've helped companies stand up their own threat hunting teams, their own detection engineering teams, and this is critical to be able to speak up to the board and stuff like that. So let's jump to the fun stuff, technical detections, right? So whenever I talk about an analytic, I always talk about these 3 KPIs. These are performance indicators that we measure every single analytic. Step 1, you have to, actually I'm gonna go out of order. Step 1 is low false positive. That's the one that everybody gets right. If you don't get this one right, your SOC and alert team picks up the phone or they just start shutting you down and start removing your detections from the system. So everybody gets low false positives right. They make sure that these things are tuned because you don't want to clog, there's a great paper, Don't Clog the Pipeline. Was that Jared Atkinson?
Yeah, it was Jared.
Yeah, Jared from Spectre Ops read a really good Don't Clog the Pipeline. We're going to actually talk about future detection engineering, about how we want to disengage from that concept so that every single person along the timeline has their own knobs, and then we can actually flood the pipeline, but everybody has control of how much they can intake. But for right now, low false positives, that's absolutely critical. Second thing that some companies get to is the maturity around true positives. So you can use advanced tooling. There's breach attack simulations out there, right? Mandiant has MSV. There's also open source technologies like Atomic Red Team, Caldera, things like that. Your goal is for every detection you push out into the wild, do you have the true positive of that? Do you know that when Mimikatz is in your environment, that your detection really will save the day, it really will fire? Then step 3, that also begs the question of variations of an attack. And this is where we talk about robustness. When we talk about measuring robustness, this is a very advanced thing that our companies are actually working on. How much is enough? Everybody's seen the MITRE ATT&CK matrix wall of 350 squares, but there are some squares that are pretty densely packed, like PowerShell, right? You can't just deploy one PowerShell detection and then be done with it. But there's other ones that are very tuned and very specific, talking about ways to inject DLLs into LSAS to bring down credentials. Okay, there's only 3, I think maybe 4 ways that we know how to do that. So that's a very defined space. So measuring your robustness is an advanced thing that spend a little bit of time talking. You have to enumerate the total possibilities of attacks. In order to do this, we do it with sandboxing. We pre-detonate a lot of all the Cobalt Strike, Brute Ratel. We're trying to enumerate the total attack surface space of something like LSAS dumping, because every tool will do it slightly differently. And when you write a detection and you've only ever seen one true positive case, you can overfit that rule to that attack and miss 20 other variations of that attack. Either because the hacker is wily and knows how to get around it, or truthfully, just they get lucky. They just read a different blog article. When they were coding that same thing, they just thought of it differently. Or like access masks is a great thing, right? It's a hex code that you pass into a system call, but there's like 65,000 variations of it, and most detections only take the top 3 or 10 variations of that, but there's 65,000. So you need advanced tooling, advanced things, but robustness really comes down to how well are you protected, and can you measure that? Really important. And then the last thing that I always throw in there is documentation. The person that's writing the detection is not always, and in fact, likely not the person that's going to be triaging it at 2 in the morning and have to make that call, should I wake up my boss or should I not? So you need to have good documentation around it, right? Pointing to external threat intelligence. Minimum, you have to map it to MITRE ATT&CK just because everybody does that, and that does help your reporting. Brief description, listing your true positives, that's critical. If you know what true positive looks like, if you know what evil looks like, including that along with your detection as a unit test to the true positive, if you can join those two things and hand that to somebody at 2 a.m. and say, here's 15 variations of Mimikatz, then they can compare and contrast, oh, okay, here's what evil looks like, this does not look evil, false positive, and make that decision much more accurately and quicker, and that's critical. The more you can get through triaging, the faster, the better. Okay, so we're going to talk back to the IOC thing. IOCs, right? Everybody loves to hate. This David Bianco's obviously famous for this pyramid of pain. It came out in 2013, shortly after Mandiant released APT1 report, and it was really trying to convey the need for not stopping at hashes, IPs, and domains. As I mentioned, my first 16 years was more on the offensive side, so I'm very, very brutally aware. I mean, even in 2000 to 2005, we were rotating IP addresses, having binary diversity at our hash level, never deploy the same hash twice. Lots of different OPSEC type things. So even in 2005, hackers were doing these things. Fast forward to now, we are still leveraging this as a crutch. Why? Because it's just easy, right? Everybody can take an email, copy and paste, or more advanced, use Stix Taxi to push out IOCs, but you can't stop there. It's just not gonna, you're gonna miss too much. So behavioral detections, obviously that's where we all wanna be. That's all where we want to get to. What we are doing is we are imposing cost on our adversary, and that's where detection engineers really shine. They don't, my wife and I, in our family, we have this saying, don't nip at the leaves, right? Cut to the root. That's what the good detection engineers do. They reverse and understand what chess moves are on the board for an adversary, and they try and cut them off at those passes. They're not trying to stop them with a hash or an IP address or even a command line argument that could easily be compiled to something else. You have to figure out what depth you're willing to go, but that's really where we want to get people to. So it requires tremendous technical understanding. And the next thing of why we aren't at behavioral detections as InfoSec is just the inability to share them. We talked about like the word problem. When we ingest threat intelligence today, it is in a narrative form. It is a Word document or a PDF. Sometimes there's screenshots. Sometimes there's pseudocode. Hey, check out any DLLs, any binary that's loading these 3 DLLs and has a network connection out to the internet, right? These are all words, and who remembers like second grade math problem? I have a third grader, so we're always doing like the train leaves at 3 p.m. and he's traveling west at 600 miles per hour, and what time will he arrive? Nobody likes word problems. So when we're talking about behavioral detections, there's things like Sigma that are coming into play that do detection as code, and that allows us to not share transmitted words, but instead machine-readable detections that can be more easily applied into an environment. The open source community has been rallying around this. It still needs a lot of love to get it to operationalize it, but it is a tremendous step forward in sharing behavioral, TTPs, tools, and network artifacts where we used to have like Stix Taxi to share IPs, hashes, domains. Yeah, so things like shared sandbox emulation, attack emulation, detection as code, these are concepts that are kind of bringing our industry to the maturity where we can share across vendors. And now, when Andrew is deep diving on a binary from an IR, he can transmit that to a, I'm not going to name vendor names, but any of the other vendor names that are out there on the floor in code, which is super powerful. All right, so that's some of the technical stuff. Technical stuff is the stuff that gets you excited, it wakes you up in the morning, that's the stuff you love digging into. But when you really talk about how do I build a detection engineering platform program, there's a lot more to it, right? Not belittling the technical stuff, that is the hardest stuff, but we as an industry, we're forgetting all the rest of the owl. So I'm gonna breeze through this slide because we're gonna go more in depth, but just to set this up, detection engineering is really around a workflow. How do you codify the process from threat intelligence, somebody saying, hey, this is threat intelligence that we need to care about? How do you mature that? In the basic days, you're just gonna write it down on a sticky or tell your boss you're gonna get into that, and then all of a sudden, the next day there's an IR, and you totally forgot about that, right? So how do you have this process and workflow management? How do you measure your process? Super important. Security engineering. You can't do detection engineering without the data and the telemetry data. What vendor products do you have? What's your retention rate? Are you capturing the right data? Are you over capturing data that you've never written a detection to, right? Your boss is always looking for ways to cut budget. If you can understand what telemetry data has contributed to what detections, and you can show that in a report, you can say, oh, you want to cut my DNS records? Well, yeah, we can go dark on these 30 detections. Is that okay? And they'll say, no, I don't want to do that, right? So a way to justify your data spend and your data storage and your compute power is really powerful when you're trying to communicate up. Also signature management, versioning, tracking. We work with a lot of large financial institutions. They have compliance requirements, right? You can't just jump on a Splunk of a multinational 400, 500,000 employee company and start changing detections. Bad things happen. I've seen really, really bad things happening. How do you version? How do you track that? How do you test that in a pre-production way? How do you understand the ramifications? How do you be able to revert back to good? And then lastly is reporting, right? Reporting is critical. That's what makes you look good when you wake up in the morning, right? You see where you were and where you are. And there's lots of different ways that we'll talk about how to report this out. Obviously, there's MITRE. There's obviously Kanban workflows of how much effort and work has been done. There's obviously burn down charts. There's lots of different ways that we can talk about reporting.
Yeah. Okay, so moving into leveling up your detection team. This is probably my favorite part of this entire presentation. We're gonna walk through a ton of information here. It's okay if you don't get it all, but the thought here is that we basically want to provide a detection maturity matrix. And the thought here is that you should be able to look at this matrix and kind of see where you are in each category that we're gonna present. So Fred introduced a number of the categories that we're gonna talk through, but to get started, the first one we're gonna walk through is personnel. So personnel-wise, let's imagine that we're at day 0, right? All I have is really a single analyst who's really interested in detection engineering, right? They do an investigation and they identify some events that require new detection content, right? What are their choices? Well, they could do nothing with that. They could request request detection from the vendor that they're using, or they could start actually building detection content, right? Maybe the vendor that they're using enables you to write custom rules. Almost every EDR has that capability. And so as an analyst, you're like, hey, this is something malicious that we just identified. I should be able to write a rule and get that deployed for my environment. That way we don't miss that thing ever again, right? So that's step one, right? You're an analyst. There's no official process. It's just an analyst who's very interested in detection engineering and says, I can make sure that we detect that going forward. What's the next thing? Well, that analyst sort of starts maybe some kind of grassroots movement a little bit. I'm talking a little bit also internally, as we have a lot of this too in the managed defense world, but maybe you have a working group, right? So a working group of analysts who are all of a sudden, we see a number of different intrusions, and now as a process, we start writing rules, right? This is starting to become a little bit more of a solid process. You're starting to scale a little bit to the types of, you're starting to be able to scale to the detection opportunities that you have. But at this point, you're still not very mature, right? This is still just sort of a side aspect of the job. And I think it's really important to consider detection engineering as its own discipline and something that, I mean, for sure, all analysts should be able to do, but also at some point you do probably need some level of dedicated detection operations to ensure that after a rule has been deployed, that the rule itself is continuing to perform very well. The person who authored the rule does not necessarily need to be the person who's on the hook for tuning the rule and ensuring that it performs very, very well, right? This should be, in one part of the system that you're using to build your rule content, but also a dedicated detection operations team, right? So let's move forward from analyst group to dedicated engineering team. So you have a dedicated detection engineering team. They're focused on detection operations. They're focused on ensuring the rule is in the right priority queue. They're focused on connecting rules to response automations, things like those automated file acquisitions, automated data collections, right? We're starting to get a lot more maturity here. We have a dedicated detection engineering organization. Now, the next place, moving into security researching, I want to step back for just a hot second here because what we need to talk about is prioritization of detection content. So for the prior three cases, I'm kind of framing this by an analyst basically responding to detection opportunities that come from the investigations that they're working, right? So you're basically writing detection content for what you observe. What about the things that you don't observe, right? Those unknowns, right? The things that maybe your customers aren't seeing at all, but you know from blogs or public intel that things are actually happening that maybe you have no observation of. So that's where security researching, I think, comes into play really well. As a security researcher, you can keep up to date with that. You can investigate the different techniques that attackers are employing. And just because we don't have the data to observe it, doesn't mean we shouldn't be focusing on it, right? If you kind of have the self-fulfilling prophecy a little bit, if you're only writing content for what you see, what about the things that you don't see? So that's where security researching can really come into play. But the belief, and at least from our perspective, is that focus on what you see first, and then expand into what you don't see, and that's where security researching can come to play. Lastly, we have the director of detection engineering. So now you're starting to get to a point where, as a business, you're focusing on detection engineering. As a business, you take this as a very serious initiative, right? You have business level support. You're talking about detection as really as like a fundamental piece of success for the business. So you have to measure all these different things. We'll talk about like where we're going to be measuring here, but at the end of the day, this really comes down to making sure that the business sees detection engineering as a dedicated discipline that needs engineering resources, it needs content developers, it needs expertise.
Yeah, and so one thing to note is that as we go through these different categories, don't feel like you have to be all in the fives. Honestly, we were actually, we put the level 5 category as almost like a stretch goal. Our sole business is detection engineering, and so sometimes we do have these director of detection engineering. If your sole business is a bank or a financial institution, you may not mature past a certain level, but recognize where you are and where the next steps are is kind of the what we're talking about. The other thing to note when we're going through this, we have, I think, 3 more categories, is you don't have to be a 4 down the board. Sometimes it'll be asynchronously. You may have just a dedicated detection engineer that has an amazing detection process and great reporting and things like that. So you could be a 4 in one category or a 2 or a 1 in another category. But the next category to introduce is detections. Detections is obviously the lifeblood of what we do and something that we get really passionate about doing. Where everybody starts is at the beginning, right? You're trusting your vendors. You're deploying the vendors' antivirus, EDR signatures. They have their own set of tools or detections that you usually generally can't see, and you're trusting them, right? So you're trusting in them to provide those alerts, and you're triaging the alerts. So really not really much to speak of here other than trusting your vendors. But then incidents happen. And as soon as an incident happens, your boss goes, well, wait, I thought that we were protected. We bought vendor XYZ. And that's when your boss learns, aha, you need detection engineering. Vendors only go so far, and they only produce very high fidelity detections and push them out because most organizations cannot handle the amount of false positives. If everything that they knew how to detect they pushed to you, you'd be swamped. And there's been some famous breaches. Target was one of them where there was an alert in the queue that said that a breach happened, but there was too many false positives that were hiding that needle from the haystack. So vendors have honestly started tuning down detections to very high confidence detections. And if they can't detect at a very high confidence, it'll either be a silent signature or they won't pass it. So that is the gap and the opportunity for detection engineering. So then you start writing custom rules. In fact, one of the things Adam, I love, he says it every time, he goes, never miss the same threat twice. Now, if you're a bank, one might be too much. But when you get to see, the breadth of what he sees, he might see a threat in one company and then protect, the 900 other companies, but he's never going to be caught off guard. Never miss the same threat twice. I really I want to put that on a plaque. But this is where you're writing these custom rules. As soon as you start writing custom rules, sometimes you learn why the vendors don't write those rules and give them to you, because they require tuning. So you instantly start going into a world where you have to tune detections. This is a living off the land technique. My administrators are doing it every Tuesday when they push out patches. That's why I don't do this. Okay, let's exclude these boxes. Let's tune this down. Let's add not process, parent process name equals this. Certain things like that you need to be able to tune. As soon as you start getting good at tuning, I think these got reversed. As soon as you start getting good at tuning, then you say, great, I started writing custom rules, but there's lots of Sigma analytics. There's over 2,000 analytics out there. Which ones should I start employing? So you start looking to external consumable threat intelligence, as well as detection as code, and you start trying to pull that in. Now that you have that tuning, it's all about getting them in. Detections it's also really challenging when you have a vendor that's detecting on certain things that you can't see. A lot of times you might deploy an analytic that you read from a blog post that your vendor's already covering. And so we were talking a lot about how do you see into the vendor's detection capability when they don't make that obvious to you. And one of the easiest ways is breach tech simulation. It's to emulate those threats in your environment. Now, not red teams. We're not talking red teams here. Red teams are very good at mimicking an adversary. They might pick 8 squares on the MITRE attack and run through those threads. We're talking about you need hundreds, if not thousands, of variations of attack. Start testing your tools. That will tell you where gaps are for your opportunities for detection engineering. And then the last step for detections is obviously creating your own novel and interesting detections. We've had many cases where we've been spearphished by something novel. We can't find it in VirusTotal. We've talked to our security peers. Nobody's finding it. Okay, we're throwing it into IDA. We're reverse engineering it. We're understanding what kind of fingerprints and then writing detections for that as probably the highest level of detection engineering.
So the next category we're going to talk about is technology. So the first thought here is again, day zero, decentralized data and technology. Your data sources are all over your network, all over the company, and perhaps you have no centralization, right? The point is you have to log into n number of platforms to review n number of alerts, and this is really, really hard to manage across a network and really do anything at scale. So this makes it hard to do any kind of detection engineering process until you've centralized your data to a centralized location, right? You push everything to a data lake or a SIM. So at that point, well, now you have a collection of data in a centralized location, hopefully normalized, so that way, IP address, that field is the same kind of across all data sources that you have to deal with. And then you can use a common language to start expressing detection content, right? So your Splunk queries or your URL rules, your HXIOCs, whatever it is, right? You want to be operating in a single language. So at this point, you have your data centralized into a single location, right? The next thing is we need to start building out the processes to actually build custom detection, right? So what does that look like? Well, it looks like a lot of the stuff that Fred already talked about, right? Your syntax validation, your metadata, your unit testing, your volume testing. Really, you're making sure that your rule is as robust as possible. You don't want it to be easily evaded by attackers. So at that point, you need a technology system to really handle that end-to-end workflow of creating detection content, right? Otherwise, you're just, potentially a person operating in Notepad, creating a YARA rule, then pushing it and hoping that everything works out great, right? That's not a very mature system. We want to have a system designed to actually, make that, basically enable an analyst to springboard into detection content as quickly as possible. Moving into the next one, again, kind of following that same security researching idea, reversing malware and novel detections. Having a detection lab where you can sort of detonate malware, you can run different commands, different procedures that are implementing a MITRE technique. At that point, you can generate telemetry, again, for the things that you are not observing. So really, we want to consider, what is it that we're not seeing, and how do we generate the data for that? Next thing is having a detection engineering platform, right? Having a platform that really is designed to facilitate all of these different pieces that we've gone through.
Yeah, so, that's okay. And detection engineering platform can be anything from GitHub to some more sophisticated. We've each created a very interestingly unique, or not unique, way of doing detection engineering platform. So if you're interested, come speak to us afterwards. We're happy to dive into more kind of our processes there. But process, super important, wicked important. So everybody starts with no process, right? Boss says this is important, threat intel team says this is important. You just have it in your brain, or maybe you jot it down in your daily OneNote, but you're actioning based off of kind of memory. Then you start writing things down. We operated from an Excel document. We did large consulting threat hunting across many different organizations. So we would have an Excel document full of our detection engineering queries. We would have to port them manually. Oh, today we're on a Tanium. Tomorrow we're at CrowdStrike. Tomorrow we're at FireEye HX customer. How do we keep track of these detections? How do we hunt appropriately across vendors? So Excel did not scale for us at all. We started then ticketing, Kanban boards. Kanban boards or sprints. This is how we operate today. We have really good processes. We sometimes pick themes. So we'll say, all right, this 2-week sprint is going to be T1003.001, and we'll go deep on that. Or maybe we'll pick like 3 or 4, and we'll go deep on that. Another team I've seen do threat actor based. Another team might be tool based. So I think like 2 weeks ago, we went really hard at Brute Ratel when that was in the news, right? So Brute Ratel or CrowdStrike, Cobalt Strike. So really, really important. Ticketing Kanban. Then once you have it in a ticketing process, the next most important thing is to do peer reviewing. This is so critical for teams. It brings your teams together. You're not just working on your detection, you're actually getting to see your peers' detection. You can learn from that. It's almost paired programming in the coding world. We do paired programming. Peer review is exactly the same. They might think of brittleness in your detection that you might not have caught. They might, it's always this like challenge to show somebody else your code. So it's always going to be higher quality when you have this peer review process. But you need to have ticketing and Kanban in place to be able to unlock this level. And then the last and really super important is detection as code. We talked about Sigma. There are even more operational ways to do Sigma and deploy that. But this is so critical. We have helped many, many customers transform from one platform that might be aging to a brand new cloud-based platform. And when they have 500 rules, 800 rules that they're manually having to convert, that's a really painful process. It could take 6 months for our last engagement. Having detection as code, you can compile the same exact analytic to Splunk, to Microsoft Defender for Endpoint, to FireEye HX or Trellix HX. You can do this translation with a click of a button for 85%. We found 85 to 90% of the detections that we were doing were actually translatable. So super powerful technology that I'd highly encourage.
Yeah, so the last one here is reporting, right? Start off with no reporting, then we can talk about MITRE and really how we're mapping our rules to the MITRE attack framework. It's a common language for us all, right? That's really the value of the MITRE attack framework. It gives us a way to talk about attacks in a way that we all can understand. So mapping rules to attack, really, really powerful way to start talking at a business level on the success of your detection engineering program, right? The next thing is having a backlog, talking about your efficacy, right? So thinking about, okay, what are our detection opportunities and where are they sourced from? Are they sourced from internal investigations? Are they sourced from public intel, blogs, threat research? Tons of different categories for where you can get your backlog from. But it's a it represents the threats that you are missing, right? Your backlog is exactly the threats that you have no detection content for. So it's a very powerful statistic. Here are the things that we don't have detection for. The next thing is the coverage of opportunities over time. So kind of, similar idea here. We're talking about how much of a difference are we making in our detection backlog, right? So we want to have, one of our goals is to have coverage for basically all high severity incidents that we experience in the managed defense SOC. Like, that's our prioritization. We have something like 45,000 events that we have to go through that represent detection opportunity, right? So you have to focus on how to prioritize that and then build detection at scale to really make a big difference against that. Next thing is, are we winning, right? So what does winning look like? So I wanted to move into this kind of quickly here. I know we're almost up on time, but the first one, like Fred kept saying there, never miss the same event twice. This is one of the things that we try to live by, especially with our internal prioritization queue of really looking at detection opportunities that represent labeled events by our analysts. This, to us, was the most important thing that we could prioritize detection on. So never miss the same event twice that's fine if we see it once. After that, though, especially for the high severity events, we want to never miss that event again. So we measure that. Second one here is the ability to codify detection logic for all attack surfaces, right? You may be very, very good at detecting attacks in a Windows system or a Linux system or endpoints in general, but maybe if it's a pure network attack or it's a pure cloud attack, you have no visibility into it, right? This goes back to the maturity of centralizing all of your data into a single location and making sure you have the ability to codify attacks against all of those attack surfaces. So this is another thing that we want to measure. What can we actually detect? If an attacker is operating in the cloud only, would we know about it? And if not, that's a problem, and we need to make sure we're making a dent against that. Next thing is identifying detection gaps, especially as a MSSP or as a MDR provider here. Like, one of the things that we can look at is what does a vendor detect versus what we can add on top of that, right? So we should be able to detect whatever a vendor can detect, and then based on the visibility that we're seeing, add our own custom detection content on top of that. That's sort of the value of having an MDR service is we have the visibility and the telemetry from N number of vendors and N number of customers, right? So we should be able to identify where a vendor is not performing as well, where we can kind of fill the detection gap there. And the last one here is minimizing attacker impact. So what does this mean? We want to make sure that we're getting no ransomwares. If there's a ransomware deployment, especially for an MDR service, not great, right? That's sort of the one thing that you're kind of paying us for. So if we fail to protect you against ransomware, that's probably a big deal. The next thing is any kind of data theft, right? We want to make sure that data theft is something that isn't happening. That's as impactful as it gets. So those are kind of the four things that we started looking at on the managed defense side on how we actually measure whether or not we're winning at detection. Okay. Run through these, yeah.
Okay, so the not fun slide. That's all great. It's all rosy. It's all great, except budget, right? There are constraints to every company and every business that you need to consider. Budget is obviously at the top of the priority. Your technical SIM capabilities. We have had many times that we know exactly how to detect something, but there wasn't the technical logging or the technical implementation to do that, and that's kind of touching on data sources. Correlation engines, lack thereof. This is really critical. We go back and forth on about how we can take multiple weak signals and amplify them per host or per identity to create this bigger thing. That is something that our industry has to do way better at. Dislodging one detection from one human responding to that. That's the old way of doing it. We need to think about labeling data. We talk about it as labeling data so that you can bring these weaker signals together and understand more living off the land techniques. Response capabilities, we talked about don't clog the pipeline. If you have 10 detection engineers, is no good to you if you only have one SOC analyst, right? Understanding who is downstream from you on the detection engineering side and not overfitting or overworking them, that's critical, right? We are a team, right? We're all a team. There's a pipeline, don't clog the pipeline. And sharing threats. I could go on a whole talk about how we don't share threats enough, how There's technical limitations of sharing what knowledge we have. We were talking with Microsoft, the Nobelium guys, and they just have a wealth of knowledge, and they were like, yeah, it had to fit in a blog post article, but they just were expanding on all of the other technical detection opportunities. How do we get that knowledge out there? It's not for lack of trying, it's lack of technology that's enabling us. We don't want to be reading these threat reports that are PDF based. We have to evolve, we have to do better.
Yeah. Okay, and the last piece here, should I create an in-house detection workflow, right? So I'll just skip to the end here. The big thought here, right? We have a question, right? Should I create an in-house detection workflow? And this was, basically polled in Twitter and kind of trying to get an understanding of like what people think about this. What does the industry think? Now, there's obviously a great understanding that MSSPs and vendors are generally responsible for providing detection content for us. Like, the thought is like, should that be the only way this exists? And basically, we found that the answer is no, really. It's really a both. It's a hybrid. You should both rely on your vendor and MSSP to create detection content, but on the flip side, you will be able to create bespoke content for your environment with all the context of, again, your environment, your knowledge of your network, on top of the fact that you can be faster probably than an MSSP or a vendor. They have competing priorities. Like Fred mentioned earlier, one of the issues that we have is we have to create detection content at scale that doesn't produce a high amount of volume. That can be a really challenging problem, which means that we may produce a rule that only that has very low false positive, high true positive, but it's not capturing all the potential use cases that your environment may see. But that's something that you, as a corporation, can invest in and build detection content specific and bespoke to your environment. So the answer, blend of both. It's a good idea to, of course, rely on the vendor and MSSP, but it doesn't replace an in-house detection engineering team. All right. We have time for questions? No time for questions.
Maybe one question.
We're too wordy, yeah.
Who has the best question? We can.
Make it
we'll be
count.
standing
We can also
up
hang out
here.
over here.
We love nerding out. So yeah, if you wanna chat detection engineering or thoughts or something.
Yeah.
Too much pressure for one question.
Cool.
Well, both speakers will be up at the stage if anyone wants to approach them for more questions, but let's go ahead and give them a round of applause.
Thank you.